geobyte.
Look at the screen. It is asking like this. A soap bubble having radius 1 mm is below from a detergent solution having surface tension of 2.5 into 10 power minus 2 Newton per meter. Here, radius of the soap bubble given 1 mm, it is equal to 10 power minus 3 meters, and surface tension sigma equal to 2.5 into 10 power minus 2 Newton per meter. The pressure inside the bubble equals at a point Z naught below the free surface of water in a container. You know, the pressure inside the bubble dP equal to 4 sigma by R. Okay, and it is given that it is equal to pressure at the bottom surface of the water at a depth of Z naught. Pressure, pressure below water surface, below, listen carefully, below water surface at a depth of Z naught, let that is dP equal to rho into G into Z naught. So according to given question, this is equal to this is. That means according to given question, let me write it clearly. According to given problem, here 4 sigma by R is equal to rho into G into Z naught. Okay. Now given G value, look at the G value 10 meter per second square, and the density of water is given 10 power 3 kg per meter cube. Let's take another slide. Here 4 sigma by R equal to rho of water into G into Z naught. From this you are asked to decide what is the value of Z naught. So Z naught equal to 4 into sigma by R into rho into G. 4 into sigma given 2.5 into 10 power minus 2. Look at that value, 2.5 10 power minus 2 divided by R value 10 power minus 3 meters, rho value 10 power 3 kg per meter cube, water G10. Okay, here these two quantities are cancelling. Is equal to 4 into 2.5, 10 into 10 power minus 2 divided by 10. This 10 10 cancelled. Finally, it is equal to 10 power minus 2 meters. It is equal to 1 by 100 meters. As you know, 1 meter equal to 100 centimeters. From this 1 centimeter equal to 1 by 100 meters. It is equal to 1 centimeter. 1 by 100 meter equal 1 centimeter, because all options, look at the all options are given in centimeters. That's why I converted to centimeters. Anyhow, option C is absolutely correct. Okay, na? Similarly, look at the another important problem asking like this. A small hole of area of cross section A equal to 2 mm square. It is equal to 2 into 10 power minus 6 meter square is present near the bottom of a fully filled open tank of height of no liquid, height of the liquid H equal to 2 meters. Taking G, look at the G value, G equal to 10 meter per second square. The rate of flow of water through the open hole would be rate of flow of water. Q, discharge Q equal to rate of rate of water flow, rate of water flow Q equal, that is also called discharge, area multiplied by velocity. As you know, velocity of efflux V equal to root over 2gh. V equal to root over 2 into G10. H is 2 meters. Height of water in the tank. It is root over 40. Root over 40 I can write as root over 40 I can write as 4 into 10 can be written as 2 root 10. Units is meter per second. Okay, it is equal to area. Look at the area. 2 into 10 power minus 6 into the velocity 2 into root 10. Simplified for getting 12.6 into 10 power minus 6 meter cube per second. That is the rate of flow of water. It is also called discharge. Look at the option A. Option A is absolutely correct. Are you following clearly? Yes. Similarly, let's take the another important problem asking like this. A small sphere of radius falls from rest in a viscous liquid. As a result, heat is produced due to viscous force. Okay, because of the viscosity, heat is produced. That means heat produced equal to power produced or power due to viscosity. Right? The rate of production of heat when the sphere attains terminal velocity is proportional to. Here, as you know, rate of heat produced equal to power of viscous force or power due to viscous force okay, but as you know terminal velocity, remember this formula important. Terminal velocity vt equal to 2 into r square into density of the body minus density of the liquid into g by 9 times the viscosity. From this, I can say that, density of the body, density is the property of material. Density remains constant for both liquids and solids. Viscosity also remain constant. From this, terminal velocity is proportional to square of the radius. Okay, as you know, the rate of heat produced, I can say dq by dt is equal to 6 into pi into viscosity into radius into square of the terminal velocity. Since terminal velocity is proportional to square of the radius, square of the terminal velocity is proportional to r power 4. So here the rate of heat produced is proportional to r and vt square. Here dq by dt, rate of heat produced is proportional to rate r square r into vt square. R into, because other quantities, look at the other quantities, 6 constant, pi constant, viscosity constant. So it is proportional to radius into Vt square. But Vt square is proportional to Vt square. Vt is proportional to R. Vt square is proportional to R power 4. Correct me? Vt square is proportional to R power 4 because Vt is proportional to R square. So therefore, dq by dt, rate of heat production is R into R power 4. So dq by dt is proportional to R power 5. That is the answer. Look at the option. Look at the option B. Not option B. Option A. Look at the option A. Option A is absolutely correct. Understood clearly? Yes.
Geobyte.